actually having a user interface with a touch screen, animated touch screen. And so this was a very big accomplishment. I could say they were really ahead of their time at the moment. But this would be the beginning of Java. Later on, people jumped onto the project and it started being used in cable TV and all that. And it became a big thing. But originally, it was not called Java. Because Ling gave it a name Awk. That was the Awk programming language. But later on, they made to devise a better name for the language. And I think it came to him when he was in a cafe and he said, "Oh, what's the one thing? If you've been working on a project and you've been having coffee all through, and then this is the first realization of it that and coffee is not mostly, or the name for coffee around the US is Java. So Java being the island from which in Indonesia where coffee was first grown. So there he called it Java. So we have it Java programming language. So that's a bit of its background. So Sun Microsystems continued to develop the language, and later on it became object oriented. A lot of things that they were adding in there. So what differentiated Java at the time? For us to understand that, we need to understand how does C and C++ work. So C and C++ are compiled languages. So the code that you write gets compiled into instructions for specific type of computer to interpret. Small files called executables. And then this file can be run on that very platform that you built it for, and then used there as an executable file. So at the time, what Java was seeking to do was to build once and run everywhere concept. So what does this mean? So what they meant is that the programmers could concentrate on writing their programs, and then no matter which device that they could run on, the same code would run on all the devices. So the programmers concentrated on writing their programs, while Sun Microsystems concentrated on making sure Java was running on as many devices as possible. So how does Java run on those devices? Java sort of got an in-between strategy. So it was both compiled and interpreted. So what do I mean by that? So Java is compiled is built to bytecode, and then this bytecode now is now read and interpreted by a software called the Java runtime environment, or in this case you can call the Java virtual machine. So that is what reads the bytecode that you build from your Java code, and then it runs the application on the device on which the Java runtime environment or virtual machine is installed. So that is all beautiful. It looked very beautiful. Code once, run everywhere. So what were some of the features that came with Java? Java was very robust. It could run on consumer devices, called cellular devices. It could be used in very many other things. But some of the features that came with it was that it was a compiled and interpreted language. It was platform independent and portable. That means the code could be ported to very many other devices as long as they could support the virtual machine. And then it was object oriented. So the team at Sun Microsystems insisted and made sure that their language that they had made was object oriented. So much so that anything in Java must be inside a class or an object for it to be used. That was a very beautiful innovation. That way, programmers could start looking at code in real life, because real life is object oriented. You understand? Very many pieces of things come together to make a life. So now programmers could think about their programs this way, other than the old procedure way in C, whereby everything was run sequentially. Now we could have several pieces or call them objects of a program coming together, executed at different times, called whenever each object could be called whenever it is needed, and then the program could run in object-oriented manner. This was a very big move, and I commend them for that decision. And this popularized object-oriented. And then the other thing was it was robust and secure. So we'll get through some of these things and talk about the details of each. It was distributed, so and it was Java did not seek to completely change everything. So they based on what was available, and so they made the syntax familiar, simple, and small, building on top of the success of C++. That way, people who were C++ developers would look at Java and it was all familiar and they could easily understand the syntax, jump in and go. And then one other feature that came with Java was that it was multi-threaded and interactive. So that means that for now, they could use multi-threading, a program that would run several parallel processing at the same time and solve different tasks on different threads. This was very groundbreaking. And then it was high performance, dynamic, and extensible. So that's Java generally, and it got so popular at the time. This was the time when HTTP protocol started, and for somehow the Mosaic browser came on, and then Java and Gosling and this team at Sun Microsystem realized that Java should align itself with the internet at a time that was a thing that was booming and starting in its infancy. This helped so much to popularize Java, and it branded itself as the programming language of the internet. So everything started from there and on. So with all this success, the team at Sun Microsystem decided to make different Javas for different classes of devices that was out there. So they made the Java Standard Edition or Java SE, which was for the home computer, and then they made the Java ME, which was for the embedded devices, the small devices, the phones at the time, and then they made the Java EE, which was for the internet and servers in the enterprise world. As we speak right now, Java runs almost 90% of enterprise applications that are running on cloud. So it has been a very, very popular language being used in retail, finance, NASA, in research, a lot of things, MATLAB, science, quite a lot of applications using Java right now on the internet and on personal computers. And to mention but a few, that if you own an Android phone, then the basic underlying of the Android operating system is Java based. So that means that it's one of the biggest successes of modern day world programming and software engineering. So in a nutshell, we can say that Java can be described as a multi-purpose, strongly typed, and object-oriented programming language in a very simple statement. Strongly typed. Java is very, very strongly typed, and we shall continue to talk about this here on this channel at Stack Solving Core Java, and we shall discuss why we need statically typed languages, and those that are not statically typed languages. We shall try and dig deep into the comparison and the understanding of the differences and which wins today in programming in small systems and big systems. So let's look at the features of Java one by one. And we started out by saying Java was a compiled and interpreted language. Try to explain that, but basically what we're saying is that Java combines the power of compiled language with the flexibility of interpreted languages. So the compiler, or the Java compiler, compiles the source code into bytecode. Then the virtual machine, or the JVM, executes this bytecode by transforming it into machine-readable code. So that is how Java uses both the compiled and interpreted architecture, and it has worked wonders for Java. And that leads us to the next point where we're saying that Java is platform independent and portable. So how does that bring us to this point? So this point is that now the two-step compilation process whereby we are having first to the bytecode and then later the Java machine to the machine code. That two-step compilation process is what lies behind Java's most significant feature, the platform independence, which allows for portability. Being a platform independent means a program compiled on one machine can be executed on any other machine regardless of the operating system. As long as there is a Java virtual machine installed on that machine, then your code will run exactly the same way it ran on a different machine, and on this one it will run exactly the same throughout all machines on which a Java virtual machine is installed. So that means you build your code once and you can run it everywhere on any device that has a Java virtual machine installed. The portability feature refers to the ability to run the program on different machines. So in fact, the same code will run identically on different machines, as I was saying. Okay, so that gives programmers the power to have one piece of code and it doesn't have to change it, whether it's on a Windows machine and a Linux machine or a Unix machine or any other programming language or any other operating system whatsoever. Sorry. So that's the power of portability of run once, code once and run everywhere for Java. And then the other point we talked about is that it is object oriented. So Java strongly supports object-oriented programming concepts such as encapsulation, abstraction, inheritance, and all the instruction and data in Java program have to be added inside the class or object for them to be used. So this shows you what length did the design team at Sun Microsystems take object oriented, and we'll discuss some of these different aspects of object oriented in relation to Java in later videos and in later tutorials. And so if you are setting out and you're trying to understand object oriented programming, please like and subscribe this video so that you can get a notification when we release this kind of videos, because they shall be coming surely not too far from now. So that is object oriented. And then also it was robust and secure, and this was sort of stemming from the from the pitfalls that were existing in the previous languages of C and C++ that were popular at the time. And so how does now Java bring robustness and security to the scene? So Java includes several useful features that help us write robust and secure applications. One of the most important one is the memory management system. So Java put a lot of emphasis on memory management system along with automatic garbage collection, and so these are missing in C++. Java avoids the concept of explicit pointers. Those of you who have done C++, you understand these explicit pointers, and doesn't require programmers to manually manage the allocated memory. So that means that the garbage collector manages the memory and slowly puts out of action that memory instances that are no longer needed. So instead, the garbage collector will take care of deleting unused objects to free up memory. In addition, Java is strongly typed language, so which is a feature that can help lower the number of bugs in an application and provide error handling mechanisms. So this strong typing feature that Java brought in is that if you were talking about a string, then you better stick to that string. If you declare a variable that is a string, it can never be a number or anything else. So that means that there are fewer bugs in the system as programs get bigger and bigger, because in comparison to languages that are not statically typed, you will find that you could declare a variable, say var x, okay, and then down the road you can say x equal to boy as a string, and then shortly after you could say x equal to 1 as an integer. So this opens your application for bugs later on uh, during service. So because then it means that the language does not tell you before at compilation that there is going to be a problem, that this variable you're trying to attach to this value you're trying to attach to this variable are of different types. So at compilation that passes, and that will become a problem at runtime. So while the program is running in its life, someone enters a number in a place where there was supposed to be a string. That may not even a problem. Enters a string of character in a place that was not supposed that was supposed to be for number, and now this will result into an error or a bug in that system. So Java, being strongly typed, removed some of these bugs that can get into program lives. So those could be removed at compilation. You catch those errors, deal with them, and then move forward. Enabling people to build, enabling programmers to work with very large applications, very large files, but with managed bugs that they can trace and get, and not get lost in translation of types and so on. Then we have the other feature of being a distributed system. So this feature is helpful when we develop large projects. We can split a program into many parts and store these parts on different computers. As a result, we can easily create distributed and scalable applications that run on multiple nodes. Java is so good at this one. We can achieve this using the concept of remote method invocation and enterprise Java beans. So those of you that will continue, and those of you are already good in Java, you know enterprise Java beans and injection. This helps small pieces of programs be brought together to work in one code or in a distributed system, other than developing one big monolith that you maintain together with all these parts together that are hard to maintain later down the road in the lifetime of the application. And then we also talked about previously about the syntax and or how simple and familiar Java decided to go. So first, Java is simple thanks to coding style, which is very clean and easy to understand. Also, it does not use complex and difficult features of other languages, such as the concept of explicit pointers we already talked about. Finally, Java, since it's based on the existing language of the C++, incorporates many features of these languages. So people who were migrating from these languages found it so easy to jump onto Java and utilize all the good features that it had come on with, and hit the 1995-2000 internet boom. We already talked about the feature of multi-threading and how it helps, so also known as thread-based multitasking. So multi-threading is a feature that allows executing multiple threads simultaneously. In short, we can write Java programs that deal with many tasks at once by defining multiple threads. The advantage of multi-threading is that it does not occupy memory for each thread. All threads share a common memory area. So this is very important. So you could have two tasks run concurrently, other than the procedural way of having one task finished and followed by the other one. So for example, if you are doing a calculation and it has different parts, but this part is independent of the other, you could have a thread that goes calculates that part as while this one is going. Then once it's finished, its results can be fed into another thread, and then all that increases speed and the productivity out of Java. So there's also the point of high performance. Bytecodes that the compiler generates are highly optimized, so the virtual machine can execute them much faster. So this would be in contrast to other interpreted languages, say for example PHP, whereby at the point of while running, when you call a PHP file, then it's gonna be interpreted, and then at that point the PHP interpreters are so slow compared to the Java virtual machine, because the bytecode is optimized. So as much as it is interpreted by the virtual machine, that process is way faster than other ordinary interpreters that we know that are around. So it executes much faster, and that is why Java is faster than other traditional interpreted languages. Yes, please. Another feature of Java that is there to understand is the fact that it is dynamic and extensible. So this feature gives the facility of dynamically linked new class libraries, methods, and objects. And so Java becomes highly dynamic as it can adapt to its evolving environment. So very many people can be making different um, libraries, and then they can be compiled, they can be bundled up as jar files, and then these jar files can easily be used in other programs without having to start from scratch, and then these parts included into the existing programs dynamically used, making Java very easy to extend. So yeah, those are some of the features that we can talk about Java as a language. So this brings me to the point. Now that you understand Java, where it's come from, what it's made of, and some of the things that it has solved and made easy in the software arena, is this a language that you want to learn in 2022 going forward as a student, say, or as someone starting out your career? And my answer to this question is a very big yes. Now, I started out in Java, I think it was 2012. That was the first time I started using Java, having previously been in C and C++. I jumped onto Java. I liked the language for how easy it was and how fast I could get programs out and running. I've built a lot of systems along the way. I've built user interfaces, I've built systems, I've built servers, I've built programs for embedded devices, I've built for the Raspberry Pi, I've built a lot of things for Java, desktop applications. And I believe that Java still has a very big future and impact in the software industry now. Because when you still look through, for example, finance systems are still largely depending on Java. And Java has also evolved over the time as a technology. We see a lot of features being added into this application, starting out from JDK1, all the way. We are now talking about Java 18. So that means, and which has come out in this month of March 2022, that means that the Java ecosystem is still alive and growing, because the fundamentals of the language itself are still being improved and worked on regularly and releasing new updates every 6 months. This is a project that is not going anywhere. And since the open sourcing of Java, it has been a big blast. A lot of open source folks have jumped onto this language. The OpenJDK is moving so fast. A lot of features are making it into the language. So definitely Java is a language to use in 2022. So that I would strongly say yes. If you think Java solves the problems that you are working on as a software engineer or as a programmer, please put in all your all and learn Java, and it will be very, very productive for you. And so we look at the ecosystem of Java, for example, things that have been developed over the time that have been used, that are using Java. We could look at a lot of things. We already talked about Android. Android is a big thing. 55% of all devices, mobile devices in the world that are carried by people, are all running Android. And this is Java. So that tells you about how big this industry is, and it's not about to go anywhere. So if you know Java, it is easy for you to learn Android. It is easy to get into an ecosystem like that and become an Android app developer. So for that reason, if you are eyeing to go into the application development arena, Java would be a good skill to start with for now. From there, we could go into distributed systems, Elasticsearch, Hadoop, big data. We can talk about Cassandra. one of the biggest databases that is based on Java. We can talk about Hadoop, which is one of the biggest Apache Hadoop, some of the biggest projects that are used online in machine learning right now, which is the latest trend in computer programming and software, machine learning, and AI. And some of these applications and some of these tools that they are using have been developed grounds up from Java. So Java is a very big part of the software and the online ecosystem that it is not about to go anywhere. So if you want to go into application development, finance systems, bank systems, trading systems, management systems, Oracle, for example, uses Java on their platform to develop the Oracle ERP. A lot of Java code seated on that ERP. So I can say that Java is still very relevant and needed in this modern day age of software engineering and computer programming.